The tank that stopped burning. June 1944, Normandy, France. An American Sherman tank explodes, and its turret flies 30 feet into the air. Inside that burning wreck were 5 men. 3 seconds earlier, they were alive. 3 seconds later, they were gone. During the first months of World War II tank combat in Europe, American crews had a terrifying nickname for their own tank. They didn't call it the Sherman, they called it the Ronson. Because like the cigarette lighter advertisement said, it lights every time. But by the end of the war, something changed. Shermans stopped exploding. Tank crews who should have died walked away. And the reason was one of the simplest engineering ideas ever used in armored warfare, a system called wet-stowage. Story begins. June 14, 1944, 8 days after the massive Allied landings of D-Day. The Normandy countryside looked peaceful from a distance. Green fields, tall hedges, stone farmhouses scattered across rolling hills. But for American tank crews, the landscape was a nightmare. The French called these massive hedges bocage. Each hedge line was like a natural fortress. Thick earth embankments 2 to 4 feet high, roots as strong as concrete, dense vegetation growing above them like a wall. For infantry, the bocage slowed movement. For tanks, it created perfect ambush territory. German anti-tank guns could hide behind the hedgerows, waiting, watching. And when an American tank moved through an opening, they fired. 2 miles south of the town of Corentin, an American armored column crept through the hedgerow country. Staff Sergeant Michael Kovalski commanded the 3rd tank in line. His vehicle was an M4A1 Sherman, 30 tons of steel, powered by a radial aircraft engine, armed with a 75mm gun. On paper, the Sherman was an impressive machine. It was reliable, fast, easy to repair. But it had a problem, a deadly one. The tank's ammunition was stored in racks along the sponson shelves above the tracks. If an enemy shell penetrated the side armor, it often hit those ammunition racks. And when that happened, the tank exploded. Kovalski's Sherman rolled forward slowly, crushing grass beneath its steel tracks. Inside the turret, the crew worked in practiced silence. Corporal James Morrison, the gunner, stared through his sight. Private Danny Castellano, the loader, held a 75mm round ready beside the breech. In the driver's compartment, Corporal Hank Davies gripped the steering levers. 5 men inside a steel box. 5 lives depending on armor that was barely 2 inches thick. Suddenly, boom! The lead Sherman in the column jerked sideways. A German anti-tank shell punched through its side armor. For a 1 split second, nothing happened. Then the tank erupted. Flames burst from every hatch. The turret lifted off the hull like a cork from a bottle. A massive explosion ripped through the vehicle as ammunition detonated. The blast threw burning debris across the field. Inside Kovalski's tank, nobody spoke. They had all seen it before. They knew exactly what had happened. The German shell hadn't killed the crew. The ammunition explosion had. Kovalski grabbed the radio microphone. "Baker 3 to Baker Actual. We've got an anti-tank gun in the hedgerow. Request smoke." The radio crackled. Static filled the turret. Then the reply came back. "Negative on smoke. Continue advance." Kovalski closed his eyes for a moment. Orders were orders, but everyone in the armored divisions understood something that headquarters often forgot. Every time a Sherman was penetrated, there was a good chance it would burn. Across the battlefield, German gunners knew this too. For them, the Sherman had a predictable weakness. hit the side, hit the ammunition racks, wait for the explosion. German tank crews had watched hundreds of Shermans detonate exactly this way, from North Africa to Sicily to the fields of France. The Americans even had a grim slang term for it. They called it brewing up, because when a Sherman caught fire, it looked like a boiling kettle of flames and smoke. German tank commanders had learned to aim carefully, not at the thickest armor, but at the ammunition storage areas. And when they succeeded, the Sherman usually died instantly. Back in Kovalski's tank, the crew prepared for the worst. Castellano slid another round into the breach. "Up!" he shouted. The gunner adjusted his sight. Kovalski scanned the hedgerow through his periscope. Somewhere out there was a German anti-tank gun, hidden, patient, waiting for the next target. Then the gun fired again. The shell screamed across the field and struck another Sherman in the column. This time the explosion came even faster. The tank burst open like a bomb. Flames shot 20 feet into the air. Inside Kovalski's Sherman, Castellano whispered quietly, "Jesus." The column halted. Tank commanders shouted over the radio. Smoke shells were fired. Infantry scrambled through the hedgerows, but the damage was already done. 3 Shermans burned in the field, black smoke rising into the Normandy sky. By the end of June 1944, American armored units had already lost hundreds of tanks in Normandy. Many of those losses were not caused by catastrophic armor failure. They were caused by ammunition fires. Investigations showed something shocking. When a Sherman was penetrated, between 60 and 80% of the time it caught fire. And when it burned, the crew often had only seconds to escape. For tank crews, those seconds meant everything. Inside a burning Sherman, temperatures could reach over 1,000 degrees Fahrenheit. Ammunition cooked off, fuel ignited, explosions ripped through the fighting compartment. Men who failed to escape immediately were trapped inside. Yet even as American crews fought through the hedgerows of Normandy, engineers thousands of miles away were working on a solution, a simple idea. So simple that some officers initially dismissed it as unnecessary. But when it finally reached the battlefield, it would save thousands of lives. And the change began months earlier. In late 1943, inside a meeting room at the U.S. Army's Automotive Tank Center, a group of engineers stared at a chart of Sherman combat losses. The numbers told a grim story. Too many tanks were burning. Too many crews were dying. The Sherman's armor could be penetrated. That fact couldn't easily be changed. But perhaps something else could. The ammunition storage. One engineer raised an unusual idea. What if we surrounded the ammunition with liquid? The room fell silent. At first, the proposal sounded strange, but the concept had logic. Fire requires fuel, heat, and oxygen. If liquid flooded the ammunition racks after a penetration, the flames might be extinguished before they reached the propellant charges. The idea evolved quickly. Instead of storing shells on exposed racks, the ammunition would be placed inside sealed containers in the hull floor. Between each group of shells would be small compartments filled with water and chemicals. If a shell penetrated the armor, those containers would rupture. Liquid would spill across the ammunition, and the fire would be suppressed. The system had a name, wet-stowage, and although it added nearly 900 pounds to the tank's weight, the engineers believed it could reduce ammunition fires dramatically. But no one yet knew how dramatic the results would be. Meanwhile, in Normandy, the fighting continued. American tank crews advanced through the bocage fields. German gunners waited in ambush. Shermans burned, and the war went on. But soon, new Shermans would arrive. Shermans that looked almost identical to the old ones. Same armor, Same guns, same engines, but hidden inside the hull, a simple engineering change would transform the tank's reputation forever. When the Shermans started fighting back. Summer 1944, Normandy, France. German tank crews had always relied on one thing when fighting American Shermans. Hit them once, and they usually burned. But now, something terrifying was happening. Sherman tanks were taking direct hits and still fighting. The Americans hadn't just improved their tanks, they had changed the psychology of the battlefield. Because when a tank crew knows their vehicle might survive a hit, they fight differently. And that difference was about to cost Germany the armored war in France. The German perspective. Oberlieutenant Karl Werner studied the battlefield through his binoculars. His company of tanks was positioned along a tree line overlooking a wide farming valley. The terrain offered perfect defensive ground, long fields of fire, concealment from hedgerows, and a clear road where American tanks would likely advance. Werner's unit operated the reliable but aging Panzer IV. For years, this tank had been the backbone of German armored forces. Its long-barreled 75mm gun could destroy a Sherman at ranges of more than 1,000 meters. In dozens of battles across Europe and the Eastern Front, Werner had watched Shermans explode exactly the same way. First penetration, then the ammunition detonation, then flames. But in recent days, the pattern had begun to break. Reports from other commanders described Shermans surviving hits that should have destroyed them. At first, Werner believed it was exaggeration. Battlefield rumors often grew larger with every retelling. But now he had seen it with his own eyes, and he did not like what it meant. The ambush. Late that afternoon, dust clouds appeared on the distant road. American armor. Werner counted them carefully. 8 tanks. Shermans. They moved cautiously across the open farmland. Their turrets scanned constantly, searching for hidden threats. Werner raised his hand. His gunner prepared the main weapon. The German tanks were hidden in excellent positions. From this range, the Shermans had almost no chance of detecting them first. Range? Werner asked. 800 meters. Perfect. Fire. The Panzer IV's gun cracked violently. The armor-piercing round streaked across the field and slammed into the lead Sherman. The hit was perfect. Right side hull, exactly where the ammunition racks were stored. Werner waited for the explosion. It never came. The Sherman rocked violently from the impact. Smoke poured from the penetration hole, but the tank did not erupt into flames. Instead, something even more shocking happened. The American turret rotated, and the Sherman fired back. The return shot slammed into one of Werner's tanks. The German vehicle burst into flames instantly. Its ammunition detonated seconds later, ripping the turret open. Werner stared in disbelief. That should have been the Sherman burning, not his tank. A dangerous change. The American formation kept advancing, even after taking hits, even after losing mobility in one vehicle. The remaining Shermans pushed forward aggressively. Their guns fired rapidly, pounding the German positions. High explosive shells exploded along the tree line. Fragments tore through branches and shattered bark. Werner realized something important. The Americans were not afraid to close the distance, and that meant they believed their tanks could survive the fight. Within minutes, the German ambush collapsed. 2 Panzer IVs were destroyed. Another was badly damaged. Werner ordered a withdrawal. As his surviving tanks retreated, he looked back at the battlefield. 2 Shermans were disabled, but neither had exploded, and several American crews were already climbing out safely. That sight disturbed him more than anything else. because the Americans were surviving. Reports across the front. Within weeks, similar reports arrived from German units across Normandy. Tank commanders described Shermans absorbing hits that previously would have destroyed them. Some tanks burned, but many did not. German intelligence officers compiled the reports carefully. The pattern was clear. Something had changed in the design of American tanks. One intelligence summary read, "Recent engagements indicate American Sherman tanks exhibit improved resistance to catastrophic ammunition fires." The analysts debated possible explanations: stronger armor, improved crew training, better firefighting equipment. None of those theories fully explained the battlefield reports, because the Shermans looked exactly the same. Same shape, same armor thickness, same weapons, yet their survival rate had increased dramatically. Confidence on the American side. Meanwhile, American armored units were noticing the change as well. Second Lieutenant Robert Hayes sat beside his tank crew one evening as they prepared coffee over a small field stove. Their Sherman showed clear signs of battle. The side armor carried a deep scar where a German shell had penetrated earlier that day. Paint was blistered, steel was warped, but the tank was still operational, and most importantly, the crew was alive. Old Shermans would have blown up from that hit, the gunner said quietly. Hayes nodded. He had seen it happen too many times earlier in the campaign. But these new tanks were different. They gave crews a fighting chance, and that knowledge spread quickly through the armored divisions. Tank commanders began taking risks that previously would have been unthinkable. Shermans advanced faster. They attacked stronger enemy positions. They pushed through ambush zones instead of immediately retreating, because even if the tank was destroyed, the crew might survive. That shift in confidence had a powerful effect on the battlefield. American armored units began fighting more aggressively. Combined with overwhelming air power and artillery support, the Germans were forced onto the defensive. Within weeks, the Allied breakout from Normandy accelerated. Armored divisions surged across France. Cities fell one after another. German forces struggled to contain the advance. Behind the scenes, the factories in the United States were producing more Shermans than ever before. Thousands of new tanks rolled off assembly lines each month, and nearly all of them carried the same hidden modification: wet-stowage. A design so simple that few soldiers even thought about it, yet it was quietly saving lives across the battlefield. The engineers who saved tank crews. Winter 1943. While American tank crews were fighting and dying in North Africa and Italy, a quiet meeting was taking place inside a military engineering office in the United States. On the table were dozens of battlefield reports. Every one of them described the same terrifying problem. Sherman tanks were burning. Not just being destroyed, burning so violently that entire crews were dying before they could escape. Many never made it out. Tank crews in North Africa began giving their vehicle a grim nickname, the Ronson, after the famous cigarette lighter advertisement, "Lights every time." Engineers searched for a solution. In late 1943, engineers from several companies gathered to study the issue. Among them were specialists from General Motors and DuPont. Their task was simple to describe, but difficult to achieve: reduce ammunition fires inside Sherman tanks. At first, engineers considered increasing armor thickness, but that would make the tank heavier and slower. Others suggested relocating ammunition to the turret, but that created new safety risks. Then, one engineer proposed something unusual. Instead of simply moving the ammunition, why not protect it with liquid? The concept sounded strange. Tanks filled with water seemed impractical. But the engineers refined the idea quickly. Instead of flooding the entire interior, they designed sealed ammunition bins located in the floor of the hull. Between the ammunition racks were containers filled with fire-suppressing liquid. If an enemy shell penetrated the tank, the containers would rupture. Liquid would flood surrounding the ammunition, and flames would be extinguished before they could ignite the propellant, creating wet stowage. The new design became known as wet stowage. The name came from the liquid-filled compartments surrounding the ammunition racks, but designing the system required solving several complex problems. First, the liquid itself. Water worked well for extinguishing fires, but pure water froze during winter conditions. It also caused corrosion inside the ammunition cases. Chemical engineers developed a special mixture. The solution contained water, ethylene glycol, and corrosion inhibitors. This mixture remained liquid.
The seconds that saved lives. September 1944. Somewhere in northern France, Staff Sergeant Michael Kovalski climbed into the turret of a brand new Sherman tank. The last time he had commanded a Sherman, it had exploded. One of his crew members had burned to death in seconds. Now he was back in another tank, another steel box, another battlefield. But this Sherman was different, and he was about to find out exactly how different. Back to combat. Kovalski ran his hand across the metal ammunition bins inside the hull. They looked different from the racks in his old tank. The shells were stored lower, inside sealed compartments. Between the bins were thick metal containers filled with liquid. His loader tapped one of the containers with a wrench. "That's the new system, Sarge," he said. "They call it wet stowage." Kovalski nodded slowly. He had heard rumors about the new tanks. Some crews claimed they could survive hits that would have destroyed earlier Shermans. But rumors on the battlefield were often exaggerated. There was only one way to know the truth, and that was combat. The test. 3 weeks later, Kovalski's platoon encountered German armor near the French town of Arras. Across the field, a powerful enemy tank appeared. Through his binoculars, Kovalski recognized the silhouette immediately. Panzer tank. The Panzer was one of the most dangerous tanks of the war. Its high-velocity gun could destroy a Sherman from long range, and its thick, sloped armor made it difficult to penetrate. The Panzer fired first. The shell screamed across the field and struck Kovalski's Sherman on the right side, exactly where the ammunition racks had been in his previous tank. The impact slammed Kovalski against the turret wall. Smoke filled the fighting compartment. For a split second, he expected the same thing that had happened before: the explosion, the fire, the burning ammunition. But it didn't happen. Instead, he heard a strange sound, a hissing noise, liquid pouring across the steel floor. The wet stowage containers had ruptured. Fluid flooded the ammunition racks. The flames died almost instantly. "Everybody out!" Kovalski shouted. The crew scrambled through the hatches. One by one, they jumped from the tank. When Kovalski finally climbed out, the Sherman was still burning in the engine compartment, but the ammunition inside the hull remained intact. The tank had been destroyed, but the crew was alive. Kovalski and his men ran nearly 200 yards before stopping. They turned back and watched the Sherman burn. But this time, the turret stayed in place. No massive explosion, no ammunition detonation, just a damaged tank slowly consumed by fire. 5 men stood in the grass, alive. The difference seconds make. For Kovalski, the moment was unforgettable. In his previous tank, the ammunition had detonated within 3 seconds of penetration. 3 seconds had been enough to kill his loader, Danny Castellano. But in the new Sherman, those seconds were different. Instead of exploding, the tank had given the crew time to escape. Time that meant the difference between life and death. A statistical revolution. By late 1944, the impact of wet stowage was becoming clear. Before the modification, Sherman tanks caught fire in 60 to 80% of penetrating hits. After the new system was introduced, the fire rate dropped to around 10 to 15%. That meant an 85% reduction in catastrophic ammunition explosions. The numbers told a powerful story. Out of every 10 Shermans that would have burned before, 8 or 9 now survived long enough for the crew to escape. Why it mattered. The Sherman was never the most heavily armored tank of the war. German vehicles like the Tiger I and Panzer tank often had superior armor and powerful guns. But the Sherman had advantages that proved decisive. It was reliable. It was easy to repair. And most importantly, American factories could produce it in enormous numbers. By the end of the war, more than 49,000 Sherman tanks had been built. Thousands of them carried the life-saving wet stowage system. The Veteran Reunion. In 1947, several years after the war ended, American tank veterans gathered for a reunion. Among them were 2 men who had never met during combat: Second Lieutenant Robert Hayes and Staff Sergeant Michael Kovalski. Both had commanded Shermans in the brutal battles across France and Germany. Both had watched tanks burn, and both had survived hits in wet stowage Shermans. Inside the reunion hall stood a restored M4 Sherman. Part of the hull had been cut open to reveal the ammunition storage system. The sealed bins, the liquid containers, the simple engineering that changed the fate of so many crews. Hayes studied the display quietly. "Did you know what it was when you first saw it?" he asked. Kovalski shook his head. "No idea," he said. "My loader told me it was supposed to keep us from burning." He paused for a moment. I didn't believe him until it actually worked. The 2 men stood silently beside the tank. Both were thinking about the same thing. Friends who had not survived long enough to see the new Shermans. Tank crews who had died before the modification reached the battlefield. For them, the change had come too late. A legacy of engineering. The wet stowage system did not make the Sherman invincible. It did not end the dangers of tank warfare. But it did something incredibly important. It gave crews a chance to escape, a chance to fight another day, a chance to survive the war. Thousands of American, British, Canadian, and Allied tank crews owed their lives to that simple idea. Liquid containers surrounding ammunition, a small change in design, but a massive change in survival. Final reflection. War is often remembered from massive weapons and dramatic battles. But sometimes the most important victories come from quiet innovations. A small engineering solution, a design improvement, a simple idea that saves lives. For the crews who fought inside Sherman tanks, wet stowage meant precious seconds. Seconds that turned burning coffins into survivable vehicles. Seconds that allowed thousands of soldiers to return home after the war.